Hello students, welcome to Nilachal Polytechnic. Myself Amarendra Mishra. This is the last video class of chapter number 3, that is hydrostatics. Here in this video class, I am going to explain about the concept of metacenter and metacentric height. Before we are going to study about metacenter and metacentric height, the need of this concept is that while you are going to design a ship, the concept is really required. For submarines, you are requiring the concept of metacenter and metacentric height should be known. Let's consider there are two figures as shown in the diagram. We have seen in the first figure, the body is in vertical direction. The body is in floating condition. As it is in vertical direction, the weight of body is acting downward direction. This is the arrow mark suggesting weight of body is acting downward direction. In the earlier classes, we know about the upward force is given by the water towards the weight of body, and the weight of body in which direction the buoyancy force is also acting, and the point B is known as your buoyancy force point, or that is your center of buoyancy, at which the force of buoyancy is applied. We have seen the buoyancy force and the weight applied by the body upon the liquid, both are in a vertical direction. The center of gravity G and center of buoyancy both are on the vertical direction. Let's see, this is the area or this is the volume of liquid displaced by the body while it is immersed in it. And the center of this position of the body gives us the center of buoyancy. Let's see, the body is now tilting rightward direction. We have seen that this is the portion of the body, and this portion of the body changes its shape. We have seen that the body is tilting rightward. The amount of water will be displaced at the right position more. In the earlier case, the weight is acting along the vertical direction, but here, due to the rightward motion of the body, the weight of body is at an angle of theta, and which will making the turning effect or moment is applied by the weight of body towards the rightward. During this condition, there is a upward force or buoyancy force will be acting at point B1, where the buoyancy force shifting its position from B to B1 point. At this B1 point, the buoyancy force is applied, or it is passing through the B1 and it is intersecting the normal axis of the body at a point, and that point is known as your metacenter point. And this is the point about which the body starts oscillating when it is applied with a small angular displacement. From this, we are going to see that the turning moment produced by the weight, that will be equilibrium, same amount of turning moment will be given as resistance, that is the buoyancy force will apply the same amount of moment to that of the turning of the body. This buoyancy force will causes the body to an equilibrium condition. Due to the turning effect, theta is the angular displacement of the body, the buoyancy force changes its position from B to B1. and we are getting that the force of buoyancy line will be moving through the point B1 and intersecting the vertical line, that is at point M. During this condition, the distance between center of gravity of the body and the metacenter is known as your metacentric height. We have seen that center of gravity is G, center of buoyancy is, as shown in the figure. We are having a tilting body where there are G points metacentric height, M metacenter, B center of buoyancy. We are observing that the line of action of buoyancy force and the vertical line of the body both are intersecting at point M. Now the distance between center of gravity of the body and the metacenter point is known as your metacentric height. There are different methods are used for determination of metacentric height. By analytical method, we can determine the metacentric height as Gm is equal to I by V minus Pg, where I is known as your moment of inertia of the body about vertical axis, that is I by Y, where V is known as your volume of body actually immersed inside the liquid. Bg means that is the distance between center of buoyancy and the center of gravity of the body. Thank you all of you.